Oh, that's interesting. Okay, we'll see what happens with that. But so what you'll see there, for example, looking at the chart, we've got the letter H, and underneath that you'll see there's some numbers, right? So on the left-hand side, and this is where hopefully my tool will be quite handy.
Mr. Clayton, I think you just erased everything you approved.
Yeah, maybe I did, but we'll see. So on the left-hand side here, you can see we've got 1,022, and here we've got 1,026. So all these numbers are a measurement of the weight of the air at that particular location where the X is. Okay, so here, even underneath the L over here.
Accurate?
All right, you can see that we've got those numbers. They are accurate, yes.
Pause it.
Okay. Okay, so in terms of air pressure, the whole Earth has pressure of air on it. So a really low number that you would expect to see on a chart anywhere in the world would be about 960, is about the lowest you will ever see.
What's the difference?
And the highest that you will ever see is around about 1,040. It would be very, very, very rare that you see a number higher than 1,040.
Is that like...
So that's the range from 1,040 to 960. Okay, so if you think about 960 being a low air pressure, this is an extremely low air depression that occurs. Storms are associated with this, and in fact, cyclones are associated with these types of low numbers. Question?
Why? Why is the pressure? Why is it 960 and then 1,040?
Because some are high and some are
And the
low.
reason that's the range
Definite.
is because within the Earth, there's only so much atmosphere, and there can only be so much difference between air pressure because there's air all over the world.
Yeah.
So it's very rare. Well, it just can't happen where there's no air, and it can't happen where there's just heaps and heaps of air because the Earth's trying to balance it out all the time. Okay? Which is why also we see that these low air pressure systems and high air pressure systems are moving around. So what will happen is you get low air pressure forming and the air tries to fill the gap, moving towards it, all right? And then as it moves towards it, the air pressure rises and becomes more air in that location, and it tends to move away into other low air pressure areas. Yes?
So, you know how you said that it's about the amount of air, is that right?
Yes.
Does that mean, you know, when you walk up, say, like Mount Everest, and when you get to the top, there's, like, not very much, like, oxygen? Is that associated with your...
It is, because not only is it, do we have pockets of low and high, when you get further away from the surface of the Earth, the air pressure drops as well.
Okay.
Yeah. Okay, now...
The peak of Mount Everest.
Okay, so here we are. Now I want to identify...
There's only one L.
Because there's only one low air pressure system on our chart at this particular time. And by the way, this is today's chart. I actually copied this at recess today. So here is our low air pressure system. All right in here where that circulation is. And what we see is air moving around low air pressure system in this direction. Now I like to draw my arrows along the grey lines, okay, because what those grey lines represent is equal air pressure. Okay, we call those things isobars. We'll make a note of that soon. But we just want to keep putting our arrows on here to show that air is moving clockwise around. We have to keep following the lines. So what we can't do, we cannot, for example, assume that the air will just come up through here off the coast and back out this way. What we want to try and do is keep following the lines. Okay? So I'll go back to my little arrows and we'll keep going. Okay? So we're going this way, followed by this way. No, never. And I just looked it up one night at home.
Also, I have another question.
Yes.
Okay, so you're recording this and
Yep.
uploading it to YouTube, correct?
Yeah.
Uh,
And we'll write down what that's called. Okay. So I'm going to open up a text box. Put that here. You guys can write this down in your notes. And these, the measurement system is actually called, and it's a long word, hectopascals. Okay, so just write that down.
Do you write it as a note or under?
I'd write it as a definition because I'm going to add to this. Okay. Okay, so hectopascals, and I might just reduce the font, I think.
Is this still recording?
Yes, this is still recording.
Nice.
Okay, hectopascals. So we have
On my YouTube channel.
these. These are the unit we use to measure the weight of air. Okay, so we consider that the definition, all right? Hectopascals. Now these are numbers, okay? Now and I'll just go back to our chart here. All right, so we're back live. What I'm going to do now, we'll just put in a little bit of a note here. And it's going to be rules for working out wind direction. All right, so there are a set of rules, and we're going to talk about those right now.
Excuse me, Mr. Clayton.
Yes, Will.
Does that? I don't think that sentence makes sense. The first one.
These are the units. Yeah, that could be fixed up. These are the units we use to measure the weight of air. It should say units. Or no, the unit's okay. So when I say unit, I actually mean, like, you know how we measure distance, we use centimetres and we use metres, okay? Or if we're doing speed, we work it out in kilometres. Well, if we're doing air pressure, it's in hectopascals. Okay, so let's go back to this. So now I'm going to do a little bit of a diagram here.
Oh, diagram.
Yeah.
They use
That's good there. Okay, so firstly, here is rule number 1. When you're looking at a synoptic chart and you see the letter H, okay, the wind, and I'm going to change our colour, okay, so the wind circulates anti-clockwise around the high air pressure system. So this applies across the board. Okay, so we'll just put a little note in there, and we'll put down anti-clockwise. And you guys should be doing the same diagram.
That's so awkward.
Okay, so that's anti-clockwise.
You've got this sorted out.
Yeah, I have played with it a little bit. Okay, so on the other hand, if we have a low air pressure system where you see the letter L on a synoptic chart,
Does it have arrows around it as well?
the air, the air will circulate in a clockwise direction around it.
Ah, so if you're getting good at this.
Okay, and we'll put another note in there.
I've decided I'm going to get a new book.
Oh, every time I say that.
Can I give you my work that's still in my book?
So the wind is circulating clockwise versus anti-clockwise. Now what I'm going to do is I'm going to go back to our synoptic chart, and I'm actually going to apply these rules, all right, to the synoptic chart on the previous slide.